Number 8, we're going to select some indicators from this table that would be suitable for finding the two endpoints in this figure. So I'm going to go with the green endpoint or green equivalence point first, found at 1.0 potential, that's voltage versus the saturated calomel electrode. So I'm looking for something around 1 and finding the tris 2 bipyridine iron. That would be my first choice because that's the closest one, going from a red to a pale blue. You could also use the tris 110 phenylanthronine iron or ferroin, red to pale blue as well. I guess you could probably use the red to violet to pale blue for the tris 5 nitro, but there are other better, I was about to say more better indicators, but with the tris 2 bipyridine iron being the first choice. So for the dashed curve for this black one, so the equivalence is found right here at the triangle, and it's going to be a little bit less than the green one with the green dot. So we're looking for something that has a potential value of about 8.5. So I think the diphenylamine sulfonic acid would be the ideal choice. That would go from colorless to the red-violet, and the first hint of color would be the endpoint. Number 9, would tris 2 bipyridine iron be a useful indicator for the titration of tin with manganese EDTA? Well, we need to find out what the potential is at the endpoint. So if I have tin, the standard reduction potential of the tin is 0.139 volts in 1 molar HCl. And for the manganese EDTA, MEDTA, that standard reduction potential is 0.825 volts. So the endpoint is going to be between these two values. The tris 2 bipyridine iron here would not be a good choice because it's going to be way too high. So it wouldn't be useful for this titration. Number 10, why is iodine almost always used in a solution containing excess iodide? And that's because iodide reacts with iodine, I2, to give I3-. And that increases the solubility of the I2 and decreases its volatility. So it's a stabilizing indicator